Hello everyone, so welcome back to study room. So in this chapter we'll be learning about acceleration. Okay, so first we'll get to know what acceleration is. So acceleration is rate of change of velocity. I'll explain this in detail, don't worry. Okay, so just like our velocity was rate of change of distance, right? When we were talking about velocity, we were talking about change in position. When we are talking about acceleration, we will be talking about change in the velocity. So, have you all watched F1 race, right? So there, your velocity, your speed and your direction is changing continuously, like of the racers, right? So at that is an accelerated motion. Okay. So acceleration is rate of change of velocity. During uniform motion of an object along a straight line, the velocity remains constant with time. When we are talking about uniform motion, like we saw its graph like this, that when the body, in 2 seconds, the body has covered, suppose 1 meters. In 4 seconds, suppose 2 meters. Like 1 meter every 2 seconds if it's covering, like it's a uniform motion, right? So your velocity is constant with time. Your velocity is not changing. Your speed with direction is not changing. So in that case, that is your uniform motion, right? In this case, the change in velocity of object for any time interval is 0. Of course, if your velocity, suppose if we talk about this graph, so your velocity for 2 seconds is how much? 1 meter in 2 seconds, 1 by 2, right? Your velocity for 4 seconds is 2 meters in 4 seconds, again 1 by 2. So in a uniform motion, your velocity is constant, right? So your velocity is not changing. So if you take the difference of the two velocities, right, v2 minus v1, it will always be 0, right? If your velocity is constant, your velocity is 10 meter per second, suppose throughout, then of course, if you take any two instances and you calculate the change in velocity, it will be 0 because velocity is same at both the instances, right? So when we are talking about uniform motion, the change in velocity is 0, right? For any time interval is 0. But in non-uniform motion, velocity varies with time. So like a non-uniform motion, okay? If we think about this, for example, it is traveling 5 meters in 4 seconds, then in 20 seconds it's traveling suppose 7 meters, any arbitrary we are taking, okay? So what will happen in this case? Of course, there will be some change in velocity. It will not be 0 because our velocity is not same throughout. In uniform motion, our velocity was constant, but in non-uniform motion, our velocity is changing, okay? Thus, the change in velocity of the object during any time interval is not 0. So, rate of change of velocity or acceleration. We can say acceleration is rate of change of velocity. Rate of change of velocity means our change in velocity. For example, our initial velocity is u and final velocity is v. So, change in velocity is v minus u upon time. This is our acceleration. Okay. So, let's just read this. Acceleration is a physical quantity that measures the change in velocity of an object per unit time. So, acceleration is your change in velocity upon time taken. This is what I told you, right? A is equals to v minus u by t. Okay. So, rate of change of velocity or acceleration. Let's calculate the SI unit of acceleration. As we know that acceleration is rate of change of velocity per unit time, right? So, what is rate of change of velocity? V minus u by t, right? And what will be the SI unit of this? Meter per second, of course, because we are subtracting velocity. For example, 10 meter per second minus 5 meter per second, right? We are subtracting velocity from velocity. We'll get a velocity, right, with the SI unit meter per second. And what is the SI unit of time? Second. So from here we get is equals to meter per second square or meter second power minus 2. We can write it in both the ways. Both are same, right? So we get that SI unit of acceleration is meter per second square. Moving ahead, talking about uniform acceleration. What does uniform acceleration mean? if an object travels in a straight line and its velocity increases or decreases by equal amounts in equal intervals of time, then the acceleration is said to be uniform. For example, if an object is moving, right, I am saying that here its velocity was 2 meter per second. Then in another interval it was 4 meter per second. In another interval it was 6 meter per second. So it is increasing uniformly. Our velocity is increasing uniformly in equal intervals of time. It is increasing with same amount, right? Plus 2, then plus 2, right? So this is a uniform case of uniform acceleration. Like our velocity is increasing, but with same amount, with equal amount. So it is uniform acceleration. The motion of a freely falling body is an example of uniformly accelerated motion. When we talk about a freely falling body, for example, a ball is dropped, okay, so there is one force acting on it, that is your force of gravity, right, G, and what is it? It is acceleration due to gravity, that is 9.8 meter per second square. We'll be having a whole chapter on gravitation and we'll be studying in detail about it, but for now you should know that in a freely falling body, be it you dropped a ball, you dropped anything, okay, so you dropped something, so what happens that your acceleration due to gravity acts, which is constant, okay. Acceleration is constant, that means that velocity is increasing or decreasing in a uniform manner, right? So it is an freely falling body is an example of uniformly accelerated motion because acceleration due to gravity is acting on it, right? So now we will talk about non-uniform acceleration. As the name suggests, non-uniform, that means unequal intervals, unequal amount covered in equal intervals, right? For example, we can take a car traveling along a straight line road, increasing its speed by unequal amounts in equal intervals of time, then the car is said to be moving with non-uniform acceleration. If a car is moving with uniform acceleration, then it is covering equal amounts in equal intervals of time. But since it is moving with non-uniform acceleration, it is covering unequal distances in equal intervals of time. So let's do one example. Starting from a stationary position. If the position is stationary, what does that mean? Our initial velocity is 0, because when we are at rest, right? Stationary means at rest. So when we are at rest, starting from a rest position, of course we don't have any velocity, right? We don't have any speed. Rahul paddles his bicycle to attain a velocity of 6 meter per second. He wants to get a velocity of 6 meter per second. So this is his final velocity, right? In 30 seconds. So our time is 30 seconds, right? Okay, then, alright, correct. Then he applies brakes such that the velocity of the bicycle comes down to 4 meter per second in next 5 seconds. So in the first case, what is happening? Your initial velocity is 0 and your final velocity is 6 meter per second and your time is 30 seconds. So can you calculate the acceleration in this case? Of course, we studied that acceleration is change in velocity upon time, right? Change in velocity is final velocity minus initial velocity upon time. What is change in velocity? 6 minus 0 upon what is time? 30. So your acceleration is 6 by 30, that is your 1 by 5, that is your 0.2 meter per second square. Don't forget the units. The units, SI unit of acceleration is meter per second square, okay? Okay, so then what happens next? Then he applies brake such that the velocity comes down to 4 meter per second. If he is applying brake, so what does he want? He wants that his bicycle should stop somewhere, right? So here his final velocity will become now 0 and his initial velocity will be 6, right? In the second case, because now he is traveling at 6 meter per second, then he applies brake, right? So in the second case, what is going to happen? Your u is your 6 meter per second. The final velocity of the previous case is the initial velocity of the second case. Initial means beginning, right? So, and your final velocity is 0 because we want to stop, right? We are applying brakes, right? To stop. And what is the time? Such that velocity comes down to in next 5 seconds. Again the time, now time is 5 seconds, right? Again, what is A? A is V minus U by T. What is V minus U by T? 0 minus 6 by 5, that is your minus 6 by 5, that is your minus 1.2 meter per second square. And now you can see that acceleration is coming to be negative. What does this mean? That our velocity is decreasing with time. If your velocity is decreasing with time, then of course your change in velocity, your final minus initial, will come out to be negative, right? So negative acceleration means that our velocity is decreasing with time, okay? And we have given one name to negative acceleration, and the name is so we have given one name to this negative acceleration, and the name is retardation. Whenever our acceleration is negative, it is retardation. So you might be asked in question that a car has a retardation of something. It is nothing but retardation means negative acceleration. What does that mean? That our velocity is decreasing with time, okay? So let's do this question. When will you say a body is in uniform acceleration? When our velocity is, when will we say? You tell me. What does it mean? Increasing uniformly. What does that mean? Increasing at a constant rate. If I say that velocity is decreasing at a constant rate, then it will be negative acceleration, okay? So when we are talking about uniform acceleration, what will we say? If our velocity is increasing uniformly or increasing at a constant rate with same amount, as we discussed the case, right? If we talk about the velocity and time graph, what is happening? That for example, in 2 seconds, our velocity is 2 meter per second. In the 3 seconds, it will be 4 meter per second. In 4 seconds, it is 6 meter per second. It is increasing with equal amount in equal intervals of time, okay? What is non-uniform acceleration? If velocity is increasing with unequal amount in equal intervals of time, okay? So next question, a bus decreases its speed from 80 km per hour to 60 km per hour in 5 seconds. Find the acceleration of the bus. Okay, so it decreases its speed from this to this. This is your initial speed, right? Your U is your initial, right? 80 km per hour. And your V is 60 km per hour. One thing I want to tell you, just we did in the previous question, like 1 kilometer is equals to 1000 meters. And 1 hour is equals to 3600 seconds, and we we take this factor, right? So we can instead of doing this every time, what we can do is that we can multiply our speed with 5 by 18 when we want to convert from kilometer per hour to meter per second. So for you, so 80 into 5 by 18, okay? So that is your 200 by 9 meter per second. Okay, 80 km per hour is 200 by 9 meter per second. Similarly, to convert 60 km per hour, we'll multiply it with 5 by 18. Okay, so it's 50 by 3 meter per second, right? So you can convert this in meter per second from kilometer per hour to meter per second. Whenever you want to convert, what do we need to do? Multiply this with 5 by 18 factor, okay? Because this is what comes out, okay? Alright. So, okay, moving further. So, now we have to find the acceleration. So, what is acceleration? Acceleration is change in velocity, rate of change of velocity, right? Change in velocity upon time taken. So, what is the change in velocity upon time taken? So, it is v minus u by t. We will take both in meter per second, okay? So, what do we get? So, now what are we supposed to do now? We will subtract this 50 by 3 minus 200 by 9 upon 5, right? So upon 5. So don't do this mistake like many students do, that your initial velocity is greater in magnitude and your final velocity is smaller, and you end up subtracting the greater from smaller. You don't have to do this. You have to subtract final velocity minus initial velocity. It comes out to be nearly minus 1.1 meter per second square. You can calculate. Also, negative sign indicates that your velocity is decreasing, and you can see that velocity is decreasing, right? So acceleration has to come negative. If it comes positive, then you have solved it wrong. So this is also one way you can check your answer, okay? Moving further. A train starting from a railway station and moving with uniform acceleration attains the speed of 40 km per hour. If a train is starting from railway station, what will be its initial speed? 0, of course, because whenever something is starting, it starts from rest, right? So a train is starting from a railway station, right? So first, if it is starting, so your initial velocity is 0. It is moving with a uniform acceleration and attains the speed of 40 km per hour. Your final velocity is 40 km per hour, and in 10 minutes, and your time is 10 minutes. So let's convert everything into SI units. 40 km per hour, we'll convert it into meter per second, into 5 by 18, right? That is equals to 100 by 9 meter per second, okay? If we talk about 10 minutes, then what is 10? 1 minute is 60 seconds, right? So your 10 minutes is 600 seconds. So what is your acceleration? Acceleration is nothing but change in velocity by time taken, right? What is your change in velocity? 100 by 9 is your final velocity minus 0, because your initial velocity is 0, upon time taken. Time taken is 600, right? So your acceleration comes out to be 100 upon 9 into 6, 5400, right? Meter per second square. So this comes out to be, you can just calculate. So you can just calculate this. So it comes out to be 0.0185 meter per second square. Okay. So now we'll study about distance time graph. Okay. So what is this called? You all, like most of you, might be an avid cricket fan. So you must have seen this scoring comparison, right? So what is this called? This is called graph. Okay. So what is graph? Graphs are a pictorial representation or a diagram that represents values in an organized manner. Graphs provide a convenient method to present basic information about a variety of events. Line graph, bar graph, pie chart are the few types of graphs. Okay. So this is your line graph, pie chart is of like circle and it's divided. This kind of your bar graph, you might have studied this in your elementary classes, right? So to describe the motion of an object, we can use line graphs, right? As we were using, right, distance time graph, and we were plotting, at this very time, this much distance, at this very time, this much distance, and we are plotting this for uniform velocity. We were plotting velocity time graph, straight line graph for uniform acceleration, right? So we were using line graphs to describe the motion of an object. In this case, line graphs show dependence of one physical quantity such as distance or velocity, or another quantity such as time. Okay. So now we will be studying about distance time graph. So as the name suggests, distance is your change in position from one place to this. If this is your distance, it is simply your change in position, right? So change in position of an object with time can be represented by distance time graph. Of course, we were doing this earlier also, right? Distance time graph can be employed under various conditions where objects move with uniform speed, non-uniform speed, or remain at rest. Okay. So let's see one graph. So here your y-axis denotes distance and x-axis denotes time. So since, as you can see, it is going linearly, of course it is a graph for uniform velocity. If it is distance, so it is uniform speed. If here displacement was mentioned, we would have called it uniform velocity, right? So this is how the graph is given. We have discussed it earlier also that if an object travels equal distances in equal intervals of time, it is uniform motion, so uniform speed. So distance traveled is directly proportional to time taken, right? So distance time graph for a body moving with uniform speed. Okay, so now I will teach you how to interpret or draw the graph, okay? Because many of you feel this is a difficult topic, but no, it is easy, okay? So let's do it together, okay? I'll teach you. For example, first we'll be talking about a uniform motion, okay? When a body travels equal distances in equal intervals of time, okay? So it is your distance, here is your distance, here comes your time, okay? Distance time graph. Distance on y-axis and time on x-axis, okay? So if we're talking about the slope, for example, we're talking about a uniform motion. What does that mean? Equal amount of distance is traveled in equal intervals of time. For example, in 2 seconds, if a person is travelling 2 meters, in 4 seconds, he is travelling supposedly 4 meters, okay? In 6 seconds, he is travelling supposedly 6 meters, okay? So this is a uniform motion because equal amount of distance is travelled. Here also 2 meters, here also 2 meters, here also 2 meters in equal intervals of time, right? It is a uniform motion. Acha, what? Correct. So what does this line give us? This line, the line of in the graph is known as slope. And when we talk about distance time graph, so this line, the slope gives us velocity, okay? For distance time graph, this slope, this line gives us velocity. How can we calculate the velocity? Simply, for example, a person covers 2 meters in 2 seconds and you have to calculate the velocity. What is velocity? Distance upon time. So 2 by 2. So your velocity is 1 meter per second. For example, if you have to calculate the velocity for a particular time interval, right, from 2 seconds to 4 seconds. Okay, so firstly we'll see the respective distances, okay. So we can see from this graph that for 2 seconds, the person is covering 2 meters. For 4 seconds, the person is covering 4 meters. So if we have to calculate the speed of this particular place, what will we do? Simply, what we are going to do is S2 minus S1 upon T2 minus T1. So here S is your displacement, okay. So S, for this point S2 is 4, right. S1 is 2 minus 2 upon T2 is 4, T1 is 2. It comes out to be 1 meter per second, okay. So this is how you can calculate the velocity over a particular interval. You see the corresponding values of distance for that particular time and you take the difference, okay, just like there. So we take distance like S2 minus S1, okay. So here, C is here in the graph, please mark this, okay. So, for example, when your, one second. We can see from the graph as the object moves from the point A to B. For your A to B, it covers a distance S2 minus S1. How can we say? We can say like this. Firstly, this is A, okay, this point, and some like it is mentioned here, but okay. So this is your A and this is your B point and this is your C point, okay. Then for time T1, your distance covered is, you will see graphically, it meets here, right. So distance covered is S1, some S1 distance is covered in time T1. For time T2, some S2 distance is covered, okay. Okay, time T1, time T2, okay. We are taking the time from origin, okay, from this reference point. Distance S1, distance S2. if we have to calculate what distance is covered between S2 and S1, of course, this middle one, right? That is your S2 minus S1. This is the distance covered between S1 and S2, right? BC. That is your BD, like this, minus CD, okay? If we take this as D point, okay? So this is how we take out BC as the difference in the 2 points, that is your S2 minus S1. And similarly, we take the time. So total T2, this much T1. So how much time is this? If we have to calculate this time, this is the whole T2 minus this much T1, right? T2 minus T1. If we do T2 minus T1, we get this, right? So this is how we are doing this. So this is simple interpretation. Velocity is S2 minus S1 upon T2 minus T1, where S2 is your position at T2 time 2 and S1 is your position at time 1 at T1, and T2 minus T1 is your change in time, right? So here is the analysis, you can just see, of non-uniform speed. When we are talking about uniform speed, we get this graph, right? A linear graph. This is a linear graph. Here also distance time graph, so slope will give you velocity. But we can see that it is not linear throughout. It is not a straight line. So it is non-uniform, right? It is not increasing equally in equal intervals of time. It is like in 2 seconds, it is around 0.5 meters. Then 4 seconds, it is around 5 meters. 6 seconds, it is around 10 meters. There is no there is no pattern following, right? There is no equal amount, like it is unequal amount of distance is traveled, right? Amount of distance, okay? So this is your non-uniform motion. So a kind of circular curve is made here, okay? Moving further, we will be talking about distance time graphs. Of course, we have studied this. You know this now, right? Uniform motion, this is your distance, this is your time. You can also plot it like you can take equal distances in equal intervals of time, and when you plot it, you get that you get a straight line, right? A linear graph. And this is a non-uniform motion. What kind of non-uniform motion? See here, till this point it is uniform. It was uniform. Then from this to this it was uniform. From this to this it was uniform, because here it is a straight line. Here it is a straight line. Here it is, but it is a non-uniform motion. Why? Because it is covering unequal amounts. Here it is covering different kind of like different amounts. From here to here it is covering different amounts. From here to here it is covering different amounts. You can just analyze these cars, okay? So distance time graph for the object at rest. It is the easiest graph, I would say. Why do I say this? I'll just explain. You're talking about distance, displacement and time graph, okay? So of course, with time, your distance is same. This is what is happening. If your object is at rest, what does that mean? Your object is at rest. Object is stationary, okay? Even if it is 2 seconds, your distance is 5 meters. Be it 100 seconds, 5 meters. 200 seconds, 5 meters. Your object is completely not moving. So of course, there will be no speed, their velocity, initial velocity, final velocity, everything will be 0. And your object is at rest. So your graph is parallel to x-axis, right? You can see when your graph is parallel to x-axis, your object is at rest and your velocity is 0 throughout because there is no motion, okay? Moving further, distance time graph for the objects having different speeds, okay? Of course, more the slope, higher the speed. More the slope, higher the speed. I can also make you understand this by this. For example, 2 seconds, 4 seconds and 6 seconds, okay? Distance be 5, 10 or something, okay? 15, okay? So for this, if we talk about this slope, in 2 seconds, suppose it is covering 5 meters and in 2 seconds it is covering 10 meters. So this one is covering more distance in less time. More distance in less time. What does that mean? it is only possible if its speed is high, right? If it has higher speed, higher velocity, then only it will cover larger distance in shorter time, right? Right. So if I give you one graph like this, and I mark it A, B, C, D and E. Oh, this is so your time and distance, okay? So which one has the highest speed? Of course A. Why? Because it has the highest slope. It has the highest velocity. You can also see this, right? More distance is covered in the same time. And which has the lowest velocity? D. Why? Because least distance is covered in the same amount of time, okay? So if I have to compare their velocities, so A has greater than B, then C, then D. This is the order of your velocity. Moving further, so we will be studying about velocity time graph, okay? The variation in velocity with time for an object moving in a straight line can be represented by velocity time graph. If an object moves with uniform velocity, the height of its velocity time graph will not change with time. Of course, if there is, uniform velocity, what does that mean? That your velocity is constant or velocity is same throughout. This is your constant velocity. If your velocity, if your time is increasing 2 seconds, 4 seconds, 6 seconds, and your velocity is same, for example, let's say 5 meter per second, at 2 seconds also it was 5 meter per second, at 4 seconds also it was 5 meter per second, at 6 seconds also it was 5 meter per second. So your velocity is same throughout. At that time, it will be parallel to your time axis, okay? This is what it wants to say about uniform velocity, constant velocity. Your velocity is not changing, okay? So we know that the product of velocity and time gives displacement, right? Of course, your displacement is velocity multiplied by time, okay? We can see this from this formula. Velocity is displacement upon time. So of course, displacement is velocity multiplied by time. So what is the area enclosed by the velocity time graph? What does that give? It gives us displacement. Okay. So this area, what will this give us? This will give us displacement. Displacement was your shortest distance. So your velocity time graph will give you displacement. And what does this give us? Slope. Slope gives us acceleration. So for velocity time graph, note, for velocity time graph, your slope gives you acceleration and your area under curve gives you displacement, okay? Next. So this is the same thing explained, okay? S is equals to AC into CD. Of course, displacement is area of rectangle, AC into CD. 40 into CD, CD is your T2 minus T1. How? The whole is from O to here, from O to D it is T2. From O to C it is T1. So from C to D, CD is equals to OD minus OC. That is your T2 minus T1. So it is, CD is T2 minus T1. So it is the area of rectangle. So plot of uniformly accelerated motion using velocity time graph. We will just do this. Consider a car being driven along a straight road for testing its engine. Suppose a person sitting next to the driver records its velocity after every 5 seconds by noting the reading of the speedometer of the car. So an experiment has been done. So the velocity of the car is measured in kilometer per hour as well as meter per second at the different instants of the time. So plots of uniformly accelerated motion using velocity time graph. So this was an experiment done and this is the velocity time graph, right? If it covers equal amount in equal intervals of time, if velocity changes by equal amounts in equal intervals of time, it is a uniformly accelerated motion. Okay? Alright, correct. Of course, equal interval of time, equal amount, equal interval of time, it's uniformly accelerated motion. This is a plot. Okay. Okay, so if we have to calculate this area of ABCDE, in this particular figure, okay, we have to calculate the area of ABCDE. How can we calculate this area? Area of triangle plus area of this rectangle, right? So half into AD into DE plus AB into BC. What is AD? AD is your distance from T1 to T2. That is your total is T2. Total here from here is T1. So this is T2 minus T1, right? AD is T2 minus T1. Similarly, you can calculate this, right? Your initial velocity is at T1, your velocity is U. At T2, final velocity is V. So this will be V minus U. So this is what we'll be doing here. Okay, area of triangle plus area of rectangle. AB into BC plus half into AD into DE. So what is that? Okay, so what will be that? T2 minus T1 and V minus U. You can just see your BC and DE. So plot of non-uniform accelerated motion using velocity time graph. Non-uniform accelerated motion means sometimes velocity is increasing, sometimes decreasing, and increasing with unequal amounts maybe, right? Non-uniform can be anything. This is a non-uniform motion. This is also non-uniformly accelerated motion. Okay, any. There is no pattern. Unequal amounts increase and decrease. Okay. So different cases of S and V graph. Okay, when the object is at rest, at that time velocity is 0. So this is your distance time graph. Velocity is 0, particle is not moving. This is your distance time graph when object is at rest. This is your distance time graph with constant speed. Okay, constant speed, same speed throughout. Okay, so this is your uniform motion. Further, if this is VT graph, okay, if there is your constant speed, so there is your acceleration is 0. When your speed is constant, that means your change in velocity is 0, because throughout your speed is same, so your change will be 0, acceleration is 0. This is your VT graph when particle is moving with constant speed, same speed throughout, same velocity throughout. Okay, particle moving with acceleration. Okay, so these are some examples. And what does area under VT graph give you? It gives you displacement. Okay, moving further, let's do some questions. What is the nature of distance time graphs for uniform and non-uniform motion of an object? So you have to tell me this. If we are talking about uniform motion, distance time graph. For uniform motion, so equal distances are covered in equal intervals of time. We can see equal distances are covered in equal interval of time. You can even plot, take some values and plot it for you. You will get a straight line graph. So this is your uniform motion graph. And for non-uniform, your graph will be, you can make this, right? Non-uniform, unequal amount in equal interval of time, right? So what can you say about the motion of an object whose distance time graph is a straight line parallel to time axis? Now you have to tell me this thing. This is what I have already discussed. What does that mean? That the time, as time is increasing, distance is not increasing. Distance is not increasing, right? It is not increasing. It is constant. Distance, if distance is same, that means your speed is 0, or the object is at rest, or the object is stationary. Okay, this is the condition of stationary object. Next, what can you say about the motion of object if its speed time graph is a straight line parallel to time axis? You have to tell this. Speed time graph, velocity or speed. Okay, even in the case of velocity, the same condition follows. Okay, if it is a straight line parallel to x-axis, this means that your velocity is not increasing, right? Velocity is, your time is increasing and your velocity is same throughout. What does that mean? Your acceleration is 0, or your body is moving with uniform velocity. Uniform velocity. Okay, constant. Your velocity is constant throughout. Okay, so acceleration is 0. Next, what is the quantity which is measured by the area occupied below the velocity time graphs? You can do this also, of course. in this velocity time graph, the area, if we have to, from T1 to T2, if we calculate the area, what do we get? Area of velocity time graph gives us displacement, and slope of velocity time graph gives us what? You have to tell me. It's acceleration. Slope of velocity time graphs gives us acceleration, and area of velocity time graphs gives us displacement. Okay, smile. Okay, you need to revise all these things. Okay, so we'll meet in the next part now, and till that time I wish you all the very good luck. Do revise, and if you have any doubts, feel free to ask, and bye.